This question is based on polarization of light. Here, the setup is given where there are three polarizers kept one after the other, and unpolarized light is sent through the three polarizing shield. The relative angles of each is given, and theta 1 is equal to theta 2 is equal to theta 3 is equal to 30 degrees, and their orientation is shown in the diagram. We have to find percentage of initial intensity transmitted.
So this is a question of simple application of polarization. As we know in what we have read in the theoretical aspect of optics, wave optics, is that when an unpolarized light is passed through a polarized, then the intensity always becomes half, irrespective of the orientation of the polarized shade. But after, but the polarized light, but the polarized light, but the when polarized light is passed through a polaroid, the transmitted intensity depends on the orientation of the polaroid. So here basically an unpolarized is first passed to a polarized, this one, and then it is passed to the other two polarized. So at first when this unpolarized light is passed through this polaroid, this orientation doesn't matter doesn't affect the intensity, and the intensity will always come out to be I naught by 2. So after the first polaroid, the intensity becomes half of the initial intensity, which I have taken as I naught. So after this, the light has now become polarized. Now this transmitted polarized light is now again passed through the two polarites. Now, as you can see, these two are inclined with some angles with the y-axis, and so hence the and since the trans and since when the polarized light pass through polarizing shades, that intensity transmitted is depending on theta. So the final intensity, the intensity final, will be given by the the, the intensity initial intensity into the half because of the first polaroid. Let's name it as 1, 2 and 3. This is due to the first polaroid into cos square theta 2, which is due to the second polaroid into cos square theta 3, which is due to the third polaroid. So it's just a subsequent passing of uh, uh, light which continuously decreases the intensity. So now after putting the values of theta 2 and theta t, we get as 30 degree, we get intensity final as uh, intensity initial into 9 by 32. So the percentage of the intensity transmitted will be equals to 9 by 32 into 100%, which will give me the value as 28.125%.
Okay, this we end the video solved questions in optics.